you're not dead.
I honestly don't know how I'm not.
Hello,
Hi.
and welcome to Please Allow Paul to Teach You Things. Episode 5, What a Streak.
What a streak.
It's still happening, everybody. Thank you, everybody who did not submit your websites last week. I'm very disappointed in you.
No.
And
no, it's hard.
It's true. Websites are difficult. Take as much time as you want. And you know what? When you're ready, share it. And I'd just love to see what you come up with.
Me too.
And but today we're gonna learn about code.
Oh, code.
What is code?
This is our. Oh wait. This is our 5-week streak.
Oh, it's like concentric circles.
Well, it's like it was gonna be a rainbow, but you know.
Oh.
Anyway.
For some reason, I see like nested caves.
Oh, nested caves. I like that. Wait a second. I have the perfect drawing for code. I think you know exactly what I'm gonna do.
There you go.
This is code.
This is code. I have written down a few different definitions of what code is.
All right.
Right? And so we're just going to go through them, and I feel like they illuminate possibly different facets, but none of them are going to really capture the whole thing. And I purposefully did not look on Wikipedia for the actual definition of code. This is how I think of it. All right.
Okay.
You write down words in a language that computers understand in order to get computers to do things.
Okay.
That's how I think of coding. So you've got a language which is a programming language, right? It has a grammar, it has a syntax. You write stuff in that language, and you have to adhere to that language because computers will understand that language, but they won't understand it if you just start riffing in English. So computers understand the language that you're writing in, and then computers execute code. They do something with what you wrote down, depending on what you wrote down, obviously. So there's a few different reasons you might want to code. All right. So I'm just going to give you three examples.
Wait, is this definition correct? Code, a language computers understand.
That's pretty good. So, 3 examples.
Okay.
Of why you might code.
3 examples of why me, Megan, person who does not know how to code.
And just why people do it in general too.
Want to or learn to?
I don't know if
or need to.
I'm not trying to sell you on coding as like a good thing. I'm just saying that these are scenarios in which coding is useful.
True.
I'm not an evangelist for code. I'm just reading to you the tech specs, the perks on the box.
All right.
So 1. You can use a computer. If you can code, you can use a computer to transform data.
Ooh.
So I'll give you a personal example, something I was doing this week as a fun project. I created what's called a static site generator, which just takes a bunch of text files and it outputs a whole website, right? So it's just regular text, but after I run the program that I wrote with code, I have a whole bunch of HTML that I can just put up on the internet. So it's called a static site generator. And so I used my capabilities of coding to transform data from text to a website. Another good example of this is when you write a formula into Excel, right? You're transforming data. You have a bunch of data that is in one way, and now you want it to be added all together, or find the average, or you're doing statistics, or there's all sorts of reasons where you have data that is some way and you want to transform it to be a different way.
Okay.
I mean, does that make sense to transform data?
I mean, yeah, like transform, you mean give it a visual or practical use. So you had data, you had a bunch of words and letters and stuff. And now instead of it being words and letters, it's like in an infographic or in a window.
Yeah.
Yeah.
Yeah, you could, if you want to do it in an automatic way, because you could do it all by hand, right?
Yeah.
But
Seems terrible.
if you have a ton of data, you want to do it quickly.
Yeah.
You transform data with code. Okay, so 2. Telling computers to do electronic things.
Is this going to be like getting your LED light bulb to switch on?
That is definitely one thing. Yeah, this is a good. Thank you, Megan, for I have a long-standing project.
Great shame.
I have a long-standing project.
Might I suggest 2 wires and a potato? To do electronics.
When you learn to code, typically the first program you ever learn is called Hello World. It just prints Hello World on the screen. When you learn to code,
that's kind of cute and creepy.
Why? What's creepy about it?
I don't know. It's like your code, your computer's like, hello, world.
I guess it really depends on the intonation, huh?
Yeah, I guess. Hello world. Or maybe it's really sweet, like a baby right out of the womb enters the world and says, hello, world, which is also creepy.
Look out for me. I got some big ideas. So when you're doing code for electronics, typically the hello world example is to blink an LED light. And recently I got a embedded electronics board, a tiny little computer that you can program, and I found it very difficult. Not because the actual instruction blink an LED was difficult, but because it was hard to get the code onto the little board. So that's a problem I had. But if you think about, like, when you're using a computer, right? You have a screen, right? There's millions of pixels on that screen that, like, when you're playing a video game, they're changing like 60 times a second or more, right?
Change pretty quickly.
Printers, right? You had some information, maybe you transformed it with code. Now you want to turn that information, that JPEG, into actual dots on a page.
This is the Willy Wonka thing.
Willy Wonka thing?
Oh, I have a Wi-Fi printer. So it's like you have your information, which makes a picture, and then it breaks down and it goes above you in the air. And back over to your printer.
Think about Wi-Fi, right?
Yeah,
there's code that's telling a wire somewhere that is actually an antenna how to, like, blast Wi-Fi, and then
that's gonna blow my mind.
Right?
How's a wire an antenna?
So now you have code basically was used to create electromagnetic waves, and then those electromagnetic waves are received by a printer that understands that what they mean is that you want to print this picture. Like, it's bonkers that all works, and it is all the logic of that is code.
You said that this light bulb was actually a board, switchboard.
The LED it was embedded in a tiny little computer, right? So my laptop is a computer, with embedded electronics, like there's Raspberry Pi, or there's other tiny computers.
I've been imagining it as like a literal looking light bulb that you've been trying to. It's not.
It's a tiny little LED light that's on the circuit board.
Like on a circuit board.
Yeah. Sorry, you thought this whole time I was struggling with a light bulb?
I got really excited, I guess, but the real way makes so much more sense.
I mean, in a sense, they are almost indistinguishable from the perspective of code, right?
Yeah.
Because you just need...
Code doesn't have eyes.
From the code's perspective, you're just saying complete this circuit, right? This circuit that is currently not connected.
Where it's going, code doesn't need eyes to see the light bulb that it's going to light up. Um, so is it like a really tiny little light, like up in the corner?
In fact, there's a grid of 4 lights, and they're each labeled.
There are 4 lights.
It's LED 1, LED 2, LED 3, LED 4.
I'm gonna overload today on all of the.
Yeah.
Oh, you can't say anything else that might even remotely be a pop culture reference.
Okay.
And just start yelling.
All right. And a way to think of this board, right? So you've got those 4 lights, right?
1, 2, 3, 4.
Right. And then you have a chip, like a CPU, right?
Uh-huh. What's a CPU look like?
It's a square.
Mm-hmm. Where on this?
Put it in the middle. Let's say the CPU, put that in the middle, right?
Just take some time.
And then there's wires that go out from the CPU to each of the LEDs.
No, it looks cooler
Yeah,
than
typically
that.
they
I know.
yeah.
They're like Nito
they're
burrito
all-
looking.
Yeah, exactly.
They look really
There you go.
it's the
Nice.
opposite of a human body.
All right. So and you can label the middle a CPU, right?
CPU.
Now, how does the CPU know which lights to turn on? Code. So make another little box to the right.
Okay.
This will be the flash memory.
Should it be as big or smaller?
It's probably smaller. That's a fine size. Just need enough room to write flash,
Flash.
right? This is some flash memory that's
Like a
storing
flash drive.
the code, right?
Uh-huh.
So here I am out in the world, and I put some code on that flash drive,
Uh-huh.
and then the CPU, you could wire up flash to CPU,
Gotta wire it up.
and
Boop.
wire it to the CPU.
Boop.
So when you turn on this board, right,
Mhm.
the CPU says, what will I do today? I will look at the flash, and I will see what code is on there, and I will do what it says, right?
Oh.
And that's how it knows to, and so it's just code
Mhm.
that I wrote. My problem is just trying to get the code onto the flash.
Okay.
And that was my difficulty.
All right.
So yeah, that's telling computers to do electronic things, printing,
I just said
screens, Wi-Fi. Nice.
I said to do electronics. So
It's gonna be fine.
I'm gonna do some electronics. Okay. that was
So
number 2.
So step 3, or step 3, definition 3.
Thing 3.
This is how I typically describe code to people when they say, like, what have you been up to lately? I tell them, learning to code. And they're like, oh, interesting. What's that like? And what I tell them, so here's thing 3 is turning domain knowledge into algorithms that computers understand.
Oh my goodness.
Algorithms that computers understand.
Wait,
That's
can
code.
we focus on domain for a second? Does this have anything to do with domain name, or
No.
is this like
Domain knowledge
domain?
is like a scientist knows about, like, depending on what their domain is. If they're a biologist, they know about biology stuff. And if they're
I
a
would hope
physicist,
so.
they know about physics stuff, right?
Oh no, we got all mixed up again.
So what I'm saying here is that the overall act of coding or programming is you take domain knowledge. So let's say you're programming how a rocket works, right? You need to know physics,
Oh,
right?
yeah,
So
you do.
that's domain knowledge. That's science. But the act of coding is you take that domain knowledge and you convert it into a code, like you write it down into this programming language that a computer will understand. And so that the domain knowledge is, so the domain knowledge is physics, and then you write down physics into these algorithms in computer language, and now the computer can do things about physics.
Oh.
So like one example is there's the basic knowledge of physics of like how gravity works, right?
Yeah.
That's just it's a real simple equation. If you're writing a video game, you want gravity to exist in your video game so things fall down.
Oh, okay.
So you're taking the knowledge of how things work and then you're encoding it.
Yeah.
into
see.
code.
So like old example. Remember this? I remember in long time ago when we came out with Wii Bowling, like literally the first game.
Mm-hmm.
And I remember you being like, I'm just so impressed with the physics of this game.
I was impressed.
You were, and we would just watch those bowling pins go everywhere. Because, like, there's one where you set up, like, the 100 bowling pins and you just throw the bowling ball down and the pins go everywhere. So what you're saying is somebody had to program a Wii with literal physics.
Right.
To make that happen, or code literal physics.
And so what's interesting about that is that and this is how I tell people what I've been up to.
Mm-hmm.
Because when you're trying to code, you spend most of your time stuck.
Mm-hmm.
You're basically trying to solve a problem. And so until you've solved the problem, you are failing. So you're constantly failing. And half of the time, or some percentage of the time, you're failing because you don't understand physics.
Mm-hmm.
And half of the time you're failing because you don't understand code. Does that make sense?
That does make sense.
Sometimes you don't know the language of how to describe things, and sometimes you just don't understand the problem well enough to so with physics you need to know something about physics, but then to make that into code you have to know something about code. And so it's that two sides of nearly everything that makes it's exciting and fun and thrilling.
So I have a question.
Mm-hmm.
So from what I know, we don't really completely understand how the human brain works.
Right.
So we would not be able to like code an actual human brain, right?
Right.
So we don't need to worry about AI yet until we have the breakthrough of understanding how the human brain really works.
I mean, we can encode insofar as if you make a decision and it's logical. You know, if you like are trying to decide what cereal to eat in the morning, and you write it all down on a spreadsheet.
What am I gonna choose? Frosties or the other one from Bandersnatch? What was it? Sugar Pops.
Oh yeah.
Yeah.
Was it Frosties?
It was Frosted Flakes or Sugar Pops. I'm pretty sure.
Well, we could get it right. We could take the time to get it right.
We can. I will not forgive myself. No. Bandersnatch. Sugar Puffs, not Pops.
Frosties versus Sugar Puffs.
Yeah.
Thank you for looking that up.
So if I have to choose Frosties versus Sugar Puffs.
Now, if that decision seems to you to be arbitrary, that's probably one of those places where we don't quite understand how the brain works and how it really makes decisions.
It's a mood.
If you could encode your decision-making process into like an Excel spreadsheet, right? And so there's a deterministic algorithm that given the same inputs would always have the same outputs, then that's something we can code.
Okay.
So basically, we understand how to program humans insofar as humans are logical. And maybe some ways that are a little more intuitive than that.
It's the illogical things we have problems with. And that's why we have art.
There you go. So, yeah, we're going to do a little review.
Should I rewrite? Yeah.
I know it takes a long time to write.
Oh, that's fine. But you can just speed it up. Okay. And just hear the word algorithm and I think of YouTube. All right.
All right. I mean, algorithm, YouTube has an algorithm. Somebody came up with that in their mind, then someone wrote it down as code. And now it actually modifies what YouTube videos you see.
I was just thinking that there's probably out there like an algorithm to detect faces of Al Gore. So there's an Al Gore algorithm.
Also true. Okay, so those are the why of coding. So now I wanted to go through some of the basic elements. Let's see if I can count them. There is 1, 2, 3, 4, 5 basic elements
1, 2,
that I thought of for code.
1. What's number 1?
Variables.
Variables? Well, that's a science word.
So variables are like names for things that you want to store in a computer.
What do I want to store in a computer? I want to store my pictures. Is this right?
Hmm.
I want to store my music. I want to store my diary.
I mean,
I want to store my word processing.
these are all things that you could store in a computer, but in a program, I guess I should have been more. These are things
store
that you.
my secret GarageBand song.
See, you let's say you stored your name.
Oh.
So you would create a variable. It'd be something like let. Name. And then an equal sign.
Equal.
And then like in quotes, you'd put Megan.
Okay.
Right? And the reason you're doing this is because later in the program, you might need to work with this name, right? And but maybe you'll have other names that you'll want. So you want sort of a generic way to refer to, instead of having to write out Megan every time in the program that you need the name, because it could be, a variable could refer to a whole picture, right? It should be, millions of ones and zeros, right? So you're not going to write those out every time.
Yeah.
You just have one little name to refer to it. So typically in programs, you have something like, this is what's called a string, like a string of characters. MEGAN is a string. You could have something like a Boolean. So like, like what's something that's true,
like what
true
you
or
put
false?
in your soup. Just kidding. That's bouillon. Sorry.
What's something that's true or false?
About me?
About anybody. About anything.
About anything?
Yeah.
Let's go for a classic. 2 + 2 = 4.
All right. So 2 + 2. Okay.
Should I pick something different?
Something that's
The sky is blue. For now.
Sky blue.
Sky blue.
And don't put any space in, or you could put an underscore. Is a nice trick in programming.
Under
for
the
variables.
sky or under
sky?
sky?
And no, not underline, underscore. So sky and then underscore,
duh.
then blue.
Blue.
So sky blue equals true.
Equals true. Oh, it rhymes.
All right. And then you want a let on the left side.
Oops.
Let. You're saying, you're just saying, it's kind of like in math, right? Let's assume sky blue equals true. I'm going to write that down. This is going to be one of my propositions. Now, the thing about variables is that depending on the programming language, depending on the context, they can change.
Oh, no. Well, that is what the word variable means. So
at some point later in your program, right, you've declared sky blue.
Yeah.
Let sky blue. But at night, is the sky blue?
It's a very deep blue.
Oh, it is still. What about the sunset? Is it blue then? Is it always blue?
There's like nighttime, I'm really not sure.
So let's assume at some point in the program, and you could be lying, it doesn't matter. It's code, so it doesn't actually have to be true.
Yeah.
You say sky blue.
I can write my own truth. Is what you're saying.
Yeah, sky blue equals false. You just change your mind, and you don't have you don't say let this time. This time you just say no. So you have the earlier one. You still need.
Oh,
it needs to be declared
so I
the
do
first
a
time.
whole new sky _blue equals false.
Right.
That contradicts. Sky blue equals true.
Well, the thing this wouldn't work in math, but in programs, typically the computer is reading them one line at a time, right? So early on in the program, sky blue equals true, and then later in the program, for some reason, you need to change what sky blue equals to false. Sky blue is probably a bad example for that.
Why? No, just like, why do you gotta change it though?
Well, let's see. What's something that changes? Like think of like a logic, like, is Best Buy open? True or false? Right? I can go into Best Buy if it's open. I can't go into it if it's closed.
No.
Right? And so I'm going to check.
Well, you can, but you're going to get in trouble.
Oh, that's true. That's a good point.
Stealing, Paul.
Thank you. Thanks for the reminder.
People steal things.
Well, this is a perfect segue.
Mm-hmm.
Let's do number 2.
Oh. Boop-a-doo-doo. Number 2.
Conditionals.
Conditionals.
All right.
So some things are done on condition.
Yeah, on a condition, which is typically like a true or false, right?
Mm-hmm.
So like if the sky is blue, it would be a conditional. If so you could write down let sky equals true. let sky underscore equal no, wait, was it sky blue? There you go. Thank you.
I remember things sometimes.
Let sky blue equals true, right? That was a variable assignment we made.
Yeah.
Now we'll write a conditional.
Mm-hmm.
If sky underscore blue. Now, opening bracket, like the squiggly bracket.
Oh, this one?
Yeah. Yeah. Now, if the sky is blue,
Mm-hmm.
I don't know what you want to do. Go to Best Buy.
Oh.
You're doing
if the
something.
sky is blue, go outside.
Oh, there's a good one.
You don't know how many times in your life you're going to get to see a blue sky. It's very beautiful. Just go outside.
Right. And then end squiggly.
I thought this was going to be, I still had my mind on variables. I was thinking like, if sky blue, then daytime. If sky blue, but
I mean,
sunset or something.
There is
going to change.
There is an aspect where you can derive information, right? If sky blue, like you could do if sky blue and then inside of the brackets, because basically the computer's looking at this like line by line, right?
Mm-hmm.
And it gets to this if statement, if sky blue, and it's like, well, is sky blue? And it goes and checks, right?
Mm-hmm.
And only if sky blue equals true does it do the stuff inside the brackets.
Oh, okay.
Right? And if sky blue is equal to false, it just skips that line.
Oh, okay.
But one thing you could do is if sky blue,
Mm-hmm.
go outside and then also wait for 8 hours and then set sky blue to false. I mean, this is kind of absurd logic at this point.
So here also.
Yeah, still inside of the brackets.
Wait. Just wait.
Wait 8 hours.
8 hours.
And then, good chance the sky's not blue anymore. So sky underscore blue, false.
Mm-hmm.
And that's also inside of the brackets.
Oh, this goes inside of the bracket?
Mm-hmm.
Oh, goodness.
I mean, you could put it outside the brackets, but in this logical scenario, which is a weird... I mean, another, like, they're perfect.
Okay.
And the other thing about conditionals,
Mm-hmm.
a lot of times you will have an else statement as well.
What's an else statement?
So, right, if sky blue, and then it does everything in the squigglies,
Mm-hmm.
right? And then outside of that last squiggly, the word else,
Mm-hmm.
and then new squigglies, new brackets, do everything inside of these brackets.
Oh, so so the sky is not blue.
Right.
So the else is our false.
Right. If
So what do
sky
you do?
blue is false, then stay inside or
Go outside
or
anyway.
wait 8 hours or go outside.
Go outside and wait 10 minutes.
Again, this is always why domain knowledge is important. Right? You need to have a good grasp on when you should go inside and when you should go outside and how long to wait until the sky's blue. Whether or not the sky is blue at night is an important thing to know. But once you have a good grasp on what you want to accomplish, using words like if and else and putting things in brackets are how you're going to put it into code.
If pin underscore hit by ball equals true, bracket, fall down, end bracket.
Yeah.
Okay.
That's
Did I figure out physics?
that would be like one simplistic way, because think about it. Actual real physics are way too complicated to actually simulate in a computer. So you're always going to do some loosey-goosey,
Would it be
an
like
approximation.
if pin hit by ball at this angle, bracket fall at this angle,
Yeah, or you could
and this speed, and
like
this
you
speed.
could like if it's hit by, if a pin is hit by the ball, flip a coin, Yeah, or yeah,
That's not part of bowling.
you could look at the, well, just it might just be random.
I know.
Okay.
Oh, are we on to 3? Did I
Three's
jump
good.
the gun?
No, that's good.
Okay.
Let's do functions.
Functions. Like my F keys. My iPad kind of went crazy.
Yeah, again, it's really different than the F keys.
Oh, then why would they use the same gosh darn word? That's what I want to know.
So this might be, okay, so a function is something, it's an encapsulation of an algorithm. So anything that you could do in code, you can typically do inside of a function, right? But then, so let's say you wrote a whole bunch of code. Let's say you did all this logic for inside, go outside, stay, Now you could just call it outside goer function, right? And you could just have it be it's just that name. It's like a variable in a sense. It's a way to name a whole bunch of behavior. Instead of just naming a piece of data, you are storing a whole bunch of behavior to be able to refer to it later.
So my if sky blue equals true, go outside and wait for 8 hours.
Right.
Is go outside der function. Is that what you said?
Go outside function.
Go outside function.
Decider, whatever you want to call it.
Mm-hmm.
You have to come up with a name, and then you can run it over and over.
Oh, okay.
Or like the I could almost guarantee you that the physics in Wii Bowling are encoded as different functions, right?
Oh.
And so you have probably fire off a function once the pins are hit by the ball. And that function is what decides whether or not the pin goes down. So inside of that function are all the physics, right? But it's encapsulated into one little name. The other thing is interesting about functions is there's a few different kinds of them. So let's
go through the functions.
Let's do a function called add and print 2 + 2. All right.
Add and print?
Add and print 2 + 2. And typically in programming, print just means like put the text on the screen.
Add in or add
and print. And then put underscores between the words.
All of them?
And then you probably can't use a plus symbol unless you have a real fancy, weird programming language.
Well, I do. I don't know if I do. Should I also write out 2 as in TWO?
No. Number's fine.
But I just erased it.
You typically can't put a number at the start of a variable declaration. Or a function declaration. Okay. So this is your function, right? Now you have a bracket.
Okay.
Just like with the if statements. You got a bracket. And then you put in print.
Do I put it at the...
Yeah, it's a matter of taste. Print. And then 2 + 2.
Print underscore 2 + 2?
No, just print. This is why you can't typically put a plus in a variable declaration. No. See, now you're doing the actual math, right? That's why instead of writing you're not naming something, you're executing code. You're telling the computer literally add up these two numbers and then print puts them on the screen, right?
Okay.
So that's one way that you can write a function. You have encapsulated the algorithm print 2 + 2
Okay.
and give it a name called add and print 2 plus 2.
Add and
This
print.
seems silly because it is silly. So what? Another.
Well, then why do it if it's silly?
Well, so here's another kind of function.
Okay.
All right.
Oh, this was the first kind of function.
Yeah.
You were doing 3, right?
Yeah.
Yeah.
You could
Ooh.
write a function
Oh my God.
called add and print.
Underscores?
Yeah. So add underscore and print. Now do a little, do an open parentheses, and then do x, comma, y. Right? Now close parentheses.
Feels like math.
It's very much like math. I mean, this is basically what a function in math. A function is something that takes an input, like f of x, right?
Mm-hmm.
So this is f of x and y.
Okay.
The function that takes x and y,
Oh.
and what it does is it adds them together and then it prints them. So if you did the open bracket, right?
Mm-hmm. Where do I put that?
At the end of the line.
Oh.
Now, on the next line, you're going to print x plus y.
And then close my bracket?
Yep. Now, one interesting thing is print is also itself a function call, right? So but
somewhere in the world, there's print,
yeah, somebody
open bracket, blah, blah, blah,
exactly.
blah,
Somebody
close
wrote
bracket. That one's probably a very long one,
it is
I would assume.
typically a very complicated part of programming languages.
Yeah.
So add and print, right? Now we've made this basically more generic. This function does exactly the same thing as that last function if you feed it 2 plus 2 or 2 if you make x and y 2 and 2 when you call the function, right? Somewhere else in this program, this is just the definition of a program of a function. This doesn't do anything itself, but when you call the function later, you say, now is the time that I want to run add and print. You pass it 2 numbers, just like with print, you're passing it the result of x and y.
Okay.
Typically print, in fact, has a parentheses after it.
Oh.
So add and print takes 2 arguments. Those arguments are x and y.
Okay.
Print takes 1 argument, which in this case is the result of x and y. So the third way to do it, we'll just call this function add.
That's so simple.
And then parentheses x, y. And then bracket.
Oh.
And then return
Return.
x plus y.
Why return?
And then end bracket.
What's return?
Because this function is not going to print the value. So somewhere else in my program, I could write out print, then parentheses, then add x comma y, right?
Okay.
But what this function is what's called side effect free. It's not actually doing anything to the world. Like if a function says print, it's going to write something out on the screen, right? Add just takes an input, which is the x and y, and then it returns an output. Yeah, exactly. Yes, it is exactly like vomiting. You receive an input, you typically transform it somehow,
That's not where I was going with
and
this.
then you vomit it back.
He's holding his tummy. I was saying side effect free. I was gonna say Ghostbusters that. No side effects.
No side effects.
Or the thing you said. What is a computer doing but vomiting out the things you code it to do?
It works both ways. Okay, so that's functions.
You keep the vomit man, I guess.
So what have we done so far? We did variables,
Variables.
conditionals, and functions. Loops.
You have to let me come to it, otherwise I won't remember it.
Oh, okay.
It might take a really long time. but you gotta let me think of it. So then maybe I'll remember it.
Oh, okay.
I've already forgotten. Variable conditions and functions.
Yes.
Number 4.
Loops.
Loops. Wait, let's see if I can remember what are our 3 reasons for coding. I just remember number 2 is have the computer do electronic things. Number 1
is very much like a function.
Tell the computer to do things. Oh no.
What is a function? What does that side effect free function do? Or what? When you swallow food and then vomit it back, what have you done to the food?
You mashed it up.
Yeah.
You changed it.
You changed it.
You changed data.
You transformed.
You're transforming data.
Yep.
And then the third thing, oh no. So transforming data, get it to do electronic things. Is number 3 the one where I made the Willy Wonka comparison?
No, that was electronic things.
Oh no. Oh, turning domain knowledge into something computers understand. So you're making computers learn how to do science.
Yeah.
Okay.
So, 4 loops.
Loops.
This is, in a sense, the whole reason why we have computers do things instead of just doing them by hand.
Oh, yeah.
Because
makes things easier, streamlines the process.
You're a smart person.
Ooh,
you can add.
I would argue that.
You can add 2 plus 2.
Can I?
Yes, you can.
5?
I know for certain. And in fact, I can almost guarantee you that it is easier for you to add 2 plus 2 than to write a whole program to have a computer do it for you.
Or even to get out a calculator.
Sure.
Do it. Yeah.
But what if you wanted to do...
We're on number 4.
Yeah.
You know what 4 is?
What?
It's 2 plus 2.
What if you wanted to add 2 plus 2 a billion times? What if you wanted to add 1 plus 1 and then add 2 plus 2 and then add 3 plus 3 and keep on going forever? Or what if you wanted to find like the millionth digit in pi or the millionth prime number or render a video game?
Is there a computer that is trying to find prime numbers?
Yeah.
Yeah, because you can't, there's no like actual formula for it, right? You just have to do it one by one. Ooh, fun.
Yeah, there's formulas for helping computers do it, search for them fast, but there's no guaranteed quick and easy way.
Yeah.
You can actually contribute, like remember SETI at Home where you could help find aliens with your computer? There's one like that for prime numbers.
Oh, that's fun.
You can just have your computer help search for prime
So right
numbers.
now I could probably go look up what is like the highest prime number that we know so far. Ooh,
exactly.
so cool.
So loops. Computers it's just doing stuff over and over.
Okay.
It typically one way to do it is you can write loop.
Loop. Loop.
You'll get this.
I won't. There we go. Loop.
And then opening bracket.
Opening bracket.
Right.
Hello, my
Then you
friend.
could do like, I don't know, go outside.
Go outside.
Right. So.
Oh my gosh.
In this scenario, by the way, go outside is a function. It's an encapsulated behavior, right? It's a name for behavior that you're going to do.
So if I do loop, go outside, I'm referencing the other things that I wrote in the other steps.
And you're saying do it over and over. Forever.
Forever.
And computers.
Anytime the sky's blue.
No. Well, you don't have. Oh, right. You have that predicate for go outside, right? So it will do it. So what you'd want to do then is what you need to get out of this loop, because the computer will do this forever. And it's one of the first things when you're learning how to program is you accidentally write loops and you forget to cancel them.
Oh,
and so they just go, there's something called the halting problem where we
catch fire.
Where in some sense you can't know whether or not all algorithms will come to an end if they'll stop looping before the heat death of the universe. You can't know that up front other than just trying to run it sometimes. Other times it's pretty obvious that it won't. So what you need at some point to get out of the loop is to say break.
Break.
Which is just a word that you put into your program. and then you're done. You're done being that loop. So like if sky blue is false, then break.
If sky blue equals false?
Equals, in fact. So typically in programming, equals is assigning a value to sky blue. Equals means if sky blue is the same thing as false. If the value that sky blue represents, right, is false. Does this make sense?
Do I just write one equal sign?
Two equal signs. Equals.
I have to out myself. I'm not very good at math.
Well, this is a programming thing. Typically in math,
You said it's like math.
typically in math, equals is equality.
Yeah.
In programming, typically just a single equal sign is assigning a value, right? So if you just had sky blue equals false, you'd be saying, I want sky blue to equal false right now in my program. If you do sky blue equals false, you're doing logic. You're doing Boolean logic. If sky blue equals false, then break.
Then break.
And that will break you out of a loop.
Okay.
If you're stuck in there. Another way to do a loop is something that's called a for loop.
For loop.
So let's say you have a list of things, right? Like I have a list of all of the Pokemon. And I want
so many.
And I want to print each name of a Pokemon to the screen, right?
Okay.
So I say for Pokemon singular.
For FOUR or
Yeah,
FORE?
FOR.
Oh, for.
Yeah, it's a
oh
for
my
loop.
gosh, that's the easiest one to remember.
So like for
loop.
Well, so you don't have to say loop in this case. For Pokemon in the word in
underscore.
No, that's fine.
Oh.
In and then list underscore of Pokemon, right? So this will be a variable. Somewhere I have written down a list of Pokemon. And so what a for loop does, it says for each thing in this list.
So this is my variable?
That's your variable. That's the variable that's somewhere else in your program. And what Pokemon is, it's like a temporary it's like a temporary variable that you're reassigning each time you go through the loop. So like in brackets you have like print Pokemon, right? So it will look at the list of Pokemon and it'll look, okay, the first Pokemon, his name Pikachu, I will print Pikachu. Then it starts over. It looks for the second Pokemon. Second Pokemon is Bulbasaur. I will print Bulbasaur. It loops through all the items of the list of Pokemon until it reaches the end, and then it stops looping. That's a for loop. And
all right.
This list thing leads us to our last element of code.
The last element.
Number 5.
Love.
There are a lot more concepts, but these are some of the big ones. If you understand these, in fact, you can write tons of programs.
Oh.
Very well. Data structures. This is a huge concept, so we're really going to only just talk about 2 very, very common ones.
Just making some buildings.
Little structures. So the two data structures that I wanted to
should they be the same size?
talk about. No, they could be all sorts of different sizes.
Ooh.
Are arrays and objects.
Arrays.
Arrays.
Rays?
No, close. ARRAYS.
Oh, arrays.
Yeah.
Arrays.
And then objects.
Wow. Don't get to use the word arrays very often, do you? Unless it's like in a science fiction novel or something.
Well, you use it a lot in programming.
Well, Sounds like science fiction to me, Paul.
So
I think we're living in the future.
there are hundreds of different data structures. And typically what is the case is that the different data structures are better for different sets of information or different operations you want to do on information.
Okay.
So an array is typically a list of a bunch of things that are of the same type. So it's a list of numbers or a list of names of Pokemon. You can even have an array of arrays or an array of objects. So a list of things that are each one is the same. So an object could be something is like it's like a bunch of different pieces of information about the same thing. And now I'm being pretty loose and fast with the definition of object because there's different definitions of object depending on what programming language you're
Different
using.
pieces of what of the same thing?
It's different. So an object would be like a person. Like let's say Paul is an object, right? And then there's different fields. So like there's my body, there's the name, my name, there's like how tall I am. So there are different types of information, right? There's like my name, that's like a string of characters, and my age is a number. And in JavaScript, objects, those fields are named.
Yeah, different pieces of info about a thing.
Yeah.
Okay, that makes sense.
And so arrays, typically you use square brackets to work with them.
These guys?
Yeah, so square bracket, and then so it's like
different colors. Sorry.
like 1, 2, 3. Nice.
1, 2, 3.
Yeah.
What do you use for objects?
Squiggly brackets.
Ooh, just like in function.
And then you typically, like in JavaScript, for instance, you have like name, Paul, age, 33.
Do I close the bracket after Paul?
Comma.
Oh, comma. Oh, name, Paul, comma, age, 33, comma.
Yeah. So that's an object.
Type. Oh, kind of sad.
And then, okay, so this is how you store stuff in that, right? Now to get information out. This is going to be one of the very fun things about programming that we're about to learn.
Oh, no. Sounds like it's going to be complicated.
Okay.
What do you mean out? And getting my information out, like onto a computer?
Well, let's say like
Out into the world?
when you're just later on in the program, right? You stored stuff in this array, like this array of Pokemon, right? You stored all that information in the array, and the for loop is a way of getting the information out. It's making use of that information. In that case, to print.
Okay.
But let's say you can't remember, or not. No, you can't remember. You want to get the second element of this array. All right. So let's say you have this array, and you've named it. It's a variable. So let's call it my underscore array for that 1, 2, 3.
Oh, right here?
Yeah.
Oh.
Or maybe you could write it down again if you want.
Yeah, I think I should.
So
I want to do a square bracket.
yeah.
My.
But well, no. First, outside of it.
Sorry.
So you're saying let.
Let.
This is just a variable assignment. This is my.
Let me use a different color. Sorry. Let my
underscore
array.
So this is my array that I'm assigning to when I'm creating this variable. Equals 1, 2, 3, and then the square brackets around that.
Oh, well, I'm gonna use a different color. Oh, am I? Barely different, apparently.
Now, later on in the program, if you want to get something out of that array, you just write my array, my underscore array, then a square bracket, and then the number of the thing that you want to get out. Like, do you want to get the first item or
I
the
just want
second item
info number 1.
or the third item? All right, now what do you think the first item is?
Charizard?
Well, in this case, we wrote down the array. It's 1, 2, and 3.
Oh, yeah.
Right. The first Pokemon very well might be Charizard.
I have no idea which one.
But whatever the case may be, to get the first item, you need to put a 0 because it's the 0th thing, because in programming, you count from 0.
Where do I put the 0?
So my underscore array, if you, in brackets, you put 1, that equals 2. The 1th element of an array is the second element of an array.
So I need to put 0 in here?
Yeah, to get a 1 out. Right. That's the first element of the array, is 0. Does this make sense?
Just that the numbering system is different?
Yeah.
Okay.
For arrays. You count starting at 0.
Okay.
Then for objects, so you created this like Paul object up here. So let's say you called it Paul.
I get it. So 1, 2, 3, that's just the name of it. So it could be like Pikachu, Bulbasaur, Charizard. But 0 equals Pikachu.
Yep.
1 equals Bulbasaur. 3 equals Charizard. Okay.
2 equals Charizard.
Yeah, it's whatever.
Okay.
I'm on the. I might not have my names right, but I get it.
You got it.
Yeah.
All right. The object, right? Name Paul.
Name Paul.
Age 3. So let's say
Age 3.
Oh, sorry, 33. So
You are very, very intellectual for your age.
thank you.
I'm so surprised.
So
Why are we friends?
you would create that like let Paul equals bracket name Paul comma age 33 close bracket.
Wait, let
Paul. So this is a new variable called Paul.
Oh equals. Right?
Yep. Open bracket.
Open bracket. Hello, my old friend.
Name colon.
Colon.
Then Paul in quotation marks.
Paul.
Because if you just said Paul,
If your name is Paul.
right? Like the computer's reading this, and the computer sees the word Paul, and it's like, oh, that's a variable. I've seen that before. That's an object, right?
Oh, I love this computer. I love its personality.
But if you put in quotes,
I've
it's
seen that before. It's kind of like meandering around.
then comma.
This guy wrote like some kind of physics domain on me, and I'm not quite sure how it works. But
Sky blue, huh?
Is it? Let's go check. Comma. Age colon 33.
Yep.
Age colon 33.
No, if you did 33, it would be a string. This is a
XXX.
This is a literal number. No, you just can write 33. This is why you can't write variables. No. no, just actual 2 digits with a 0 decoration. I see how this can be very confusing. This is why you can't, when you're writing variables, they can't have a number at the start of them, because if there's a number to start, computer's like, that is a literal number. Okay. I know. So now,
hey,
hey,
looks like a literal number.
Now, to access this value, one of these values, let's say we want to get the age out of the object Paul. We call Paul.
What am I doing?
You're just writing in a new line. Paul. Dot. Age. Wow. And that's how you get the value out.
Oh.
So if you look at what an object is, it's just sort of like nested variables, and you just use the dot accessor to get stuff out.
Nested variables like Matryoshka doll.
Mm-hmm. Right, because you can put make an array of objects, or you could put an array inside of an object. You can make an object that has an array, and inside of that array there are objects. Inside of those objects there are arrays. You can keep going forever.
You could. I was just thinking about coding a Matryoshka doll that goes on forever. What if you put it on a loop?
It could go forever.
Just open
You
it.
keep
Keep opening it, and there's a tinier one. Wow.
That's what's that called? A fractal. That's the fractal algorithm goes on forever. You keep on zooming in, and it keeps on
being something.
Yeah, it keeps on. I don't know, more and more stuff. All right, those are the five cool parts of programming.
Okay. Ooh, can't
Want
remember.
to do some review?
No, I want to make a new layer. That's what I want to do. Did it. Don't worry about it. Okay, 1, 2, 3, 4, 5. All right. Number 1, variables. That was the one. Was that the one where we said sky_blue equals true? If sky blue, go outside.
If sky blue is a conditional. That's number 2.
How dare you tell me?
I'm sorry. But yeah, variables
it's fine.
Variables is naming things.
Because I couldn't remember what came after variables. Okay, variables equals naming things. That's a good way for me to remember it. All right, number 2, conditionals. That's you're giving your variable something to do?
Logic, maybe.
Okay. Giving my variables logic.
No, it's just logic.
Logic. I know. I didn't know. Number 3, functions. Excuse me. That's
typically
giving a name to the conditionals.
Yeah, it's encapsulation.
Oh, encapsulation of now.
And reuse.
I'm really gonna play it fast and loose with the spell of encapsulation.
Pretty sure that's correct.
Oh, let's hope so. Algorithm.
Nice.
No. Oh, number 5 is loop.
No, number 5. No.
No, number 4. Sorry.
Number 4.
Look, I got ahead of myself, but I knew that the next one was loop.
That's pretty good.
Loop. You wanna? What was the one that we used? Loop. Go outside. Do something forever until you tell it to break.
Over and over. Yeah.
Do something over and over. Oh no. Number 5. I always have a hard time remembering the last one on lists of things. Don't tell me. Well, what's the first letter?
D.
D. Domain. Oh no. What's the next letter?
A.
Oh my gosh. I'm having a really hard time.
Okay. There's a robot in
beep beep boop boop
in Star Trek Next Generation.
Data. Well, is that really what we just talked about?
Data
structures. That's why it's hard for me to remember.
That's fine.
Because
we didn't really talk about data structures.
Thank you. There's a robot in Star Trek. I know. I'm glad you know how my mind works. Data structures.
We didn't really talk about data structures in general. We talked about 2 specific data structures. This, I think, is the appropriate time to use EG.
Example. Whatever EG stands
Whatever
for.
EG stands for, I think this is the right time. I think
it's something Latin.
Yeah, it's probably Latin. But, for example, arrays and objects are data structures.
Arrays. And I shouldn't use a plus. I should use this.
Look at you thinking like a programmer. It's like, oh, plus, that's probably a reserved word in this programming language.
Use it for something else.
But I don't want to confuse the computer.
I don't. Our computer is very well. Look at that.
All right, look at this. We just covered
So pretty.
a lot of ground.
Mm-hmm.
If again, I mean, if you are good at these 5 things.
Naming things, logic, encapsulating algorithms, doing something over and over, and you know what arrays and objects are.
Then you can write most
write,
programs.
You can figure out the human brain for a computer.
Possibly. Unless it's quantum.
Oh, no. It could be.
So, what I was thinking now... we're pretty far in to the app. But what I wanted to do...
There's more?
I wanted to make a program for you to give you a vibe of what it's like to use variables, conditionals, functions,
That'll be fun. Let's do that.
and data structures.
Cool.
IRL.
That's good. Am I still drawing things?
I'm going to use my computer. So you can take a break. And you can just watch me code and see if you can follow along at home.
We'll see.
I'm hoping that I have given people the tools to follow along, but
I appreciate that you put a lesson plan together. It was very structured, just like a data structure.
Just like a data structure. Hello, this is Paul Miller speaking to you from a future that is at some point after I made this video. I've decided that this should be 2 episodes. So watch the next episode for like the tutorial segment, basically. This was the learning segment, which is now complete. Thank you.